welcome to Inspire EDUCARE. I am Ruchi and today we are going to solve question number 106 of Leetcode, that is construct binary tree from Inorder and Postorder Traversals. In this question we are given two integer arrays, Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree and Postorder is the Postorder traversal of the same tree, and we have to construct and return the binary tree. So before going into the logic of this question, it's important to know what is postorder and what is inorder traversal. So in postorder traversal, we have what we do. First we go to the left, then we go to the right, and then we go to the root. So this is the order of the postorder traversal. And for inorder, we have left to root to the right. Okay, and this is the order for inorder traversal. So for this tree, if I write a postorder traversal, right, let me create like a postorder array. What I'll do, first I'll go to the left. So first we are at the root, right? So we'll go to the left, then we'll come to the left subtree, and in this left subtree also, first we'll go to the left. So we'll get to the 4. Now 4 is the leaf node, right? So there is like no further left or right subtree, so I'll just write 4 here. Once 4 is done and I come back to the root, so once left is done, where we have to go to the right. So before going to 2, first I'll go to the right side of the 2. So this is 5. Then 5 is again a leaf node, so I'll write 5 here. And then once the left and right is done, then I'll go to the root and write 2. Similarly, for the main tree, left part is done, so we'll go to the right part before the root. So in the right part, first again we'll go to the left, that is 6. Then we go to the right and there is nothing in the right. Okay, so we'll go to the root then, because there is nothing in the right, so we'll just write the root. So now the right part of the main tree is done. So left is done, right is done. What is left? Root. So I'll write root. So this is the post order. Now for inorder, what we have to do, first we'll go to the left. So we'll go to the left subtree, right? And then in the left subtree also we'll go to the left first. So I'll write 4 here. And then I'll go to the root. So in post order, I was going to the right first, but in order, I'll go to the root first. So once the left is done, I'll go to the root, that is 2. Then I'll go to the right, that is 5. Now the left subtree is done, right? Now I'll go to the root and then I'll go to the right, and in the right also first I'll go to the left, that is 6. Then I'll go to the root, that is 3, and then I'll go to the right. So there is nothing in the right, so I'll write nothing. So this will be the inorder traversal. So this is the post order, this is the inorder, right? So in our question, we'll be given the inorder traversal and the post order traversal, and we'll have to return this tree. If I write the inorder traversal and post order traversal of this tree, it should match these arrays, right? You can write it yourself and you'll find out that the inorder and post order of this tree will be the same as the given array. And in this question, we'll have to return the tree. So we'll have to return the root of this tree, that is we'll have to return this root with the value, this node with the value 3, and so that node will be the root of the whole tree. Let's talk about the logic for this question, right? So I have drawn the example, the tree that we used before only, right? So we'll be given these as the input, post and inorder, right? So let's make some observations. We have this post order, right? In post order, I said that we go from left to right to root, right? So can I say that the last element in the post order traversal will be our root, right? Because that is the order of traversal. So when we have traversed everything, the root will be the last element of the post order. So let's say there are n nodes, right? So like nodes. So can I say that post of n minus 1, this will be our root value, right? Like root val. So this will be our root val. So this is my first observation, that my root value will be post of n minus 1, right? Now if I look in the inorder, right, this is my inorder, that is 4 2 5 1 6 3. If I find my root value in this array, which is 1, right, this is our root value, can I say that all the elements at the left represent the elements in left subtree, and all the elements in right from this root value will represent the elements in right subtree? Because in order, I said that the traversal order is left, root and right. So in this array also, all the elements to the root, this, let's say this is my index, right, the index of my root. So can I say that before this index, it will be like all the elements in left subtree, and after index it will be all the elements in right subtree, right? So our tree will look something like this. This will be a root, and in left subtree we have 4 to 5. It will be arranged in some order, and here it is 6 and 3. Now what I have to do, I will recursively write a solution where I like call the same function that I called for this root, right? So if I call like function for this to get my root of this main tree, I'll call the same function for my left subtree. I just have to create a left subtree, and I just have to create a right subtree, right? And then I'll just say that root of left is this and root of right is this, right? That will be a recursive function. So what our function will return? Our function will return the root of this tree, and when I call for this, it will return root of left subtree. When I call for this, it will return root of right subtree, right? So let's talk about how will we actually find our left and right subtree also, right? So in our post, I've already said that this will be my root, right? So let's call this root index. Let me just write the indexing for this. So this 5, let me call this root index, because this is the index of our root. So what will be our root index? It will be 5 in the Postorder Traversal, and I will find the index of my root value, that is 1, in order array, right? If I index this again, 3, 4, 5, this will be the index, right? 3 in order array. What, let's call this index, and this is 3. See, this root index is in post order array, and this index is in order array. Remember that, right? So this index is the index of the value of my root, right? Let's call this start, the like 0th index initially, and let's call this end. So what I'll do, I'll just run the loop from start to end, and if wherever I get my root index, wherever I get my root element, root value, I'll name that index as index, right? So I will find that, I have find that index. Now for left subtree, as I said that these will be the elements, right? These will be the elements in left subtree, and these will be the elements in right subtree, right? This will be left and this will be right. So can I say that for left subtree, my start will be the same, right? Start will be, let's say 0 only, and my end, because this will be the this will be the in order array of left subtree, 4 to 5. So this will be the start, it will be same, but this, the end will change, right? For the in order array, the end will change. So this will be what? Index minus 1, right? For left subtree. So start will be the same, and for left subtree, end will be index minus 1 for in order array, right? And for right subtree, end will be the same, right? And what will be the start? It will be index plus 1 for in order array, because it will be like 6 and 3. So this will be the in order array of left subtree, and this will be in order array of right subtree, right? So what we are doing, we are just changing the like starting and ending for in order array, right? And then we'll do the same thing like for left subtree to find the root of, okay, let's talk about right subtree first, then we'll talk about left subtree. To like find the root of right subtree, I already have root of my main tree, and then to find the root of right subtree, can I say that the root of right subtree will be present at root of index minus 1, right? I just will have to decrement this root index, and I'll find the root index. You can see it in this tree also. This was at the root index, that was n minus 1, right? And the root of this, my right subtree, because we'll traverse in post order, we'll traverse this right subtree also in like the same order, like left, right and root, right? So in this right subtree also, this root will come the last when I'm traversing it in post order. So in my like the post order traversal of whole tree, the root of right subtree will be adjacent to the root of the whole tree. That will be nothing but like n minus 2. Or I can say here that for right subtree, my root index will I'll just have to decrement it once, right? And I'll find the root of index of my right subtree, and then the same thing will happen. Like what will be my value of root? I'll get like root to be 3, right? Root value will be 3. Then I'll find it in my in order. This will become index, right? And then again, like this array will become left subtree, and because there is nothing here, so there will be like no right subtree for this tree, right? So what will happen? Like I'll get my root 3, and then I'll again get my like left subtree, and this 6, and then when it will go on 6, then recursively the things will happen. We'll write a base case, we'll talk about it later, right? Like that tree will become through recursive call. So for right subtree, but like this is the main point, this root index minus minus. So for right subtree, what we are doing, we are just decrementing the root index minus minus, and this root index will be where we will find it in the post array, right? Now for left subtree, we have our in order traversal. Now we have to find a root index. So if we see in the post order, like for the right subtree, what we did, we just decremented. But for left subtree, where is our root? It is here, right? It is here. So how will we get from this, from 5 to 2, how will we get here, right? Because for right subtree we just decremented 1 from 1 and it we got the root. But how will we get to the root index for left subtree, right? So this is like our current scenario. We found the root index, we have found the root index of right also, which is this, nothing but just decrementing it. Now to find the root of left subtree, what we have to see, we have to, in Postorder Traversal, we have to skip, to get to the root of left, we have to skip all the right, all the elements in the right subtree and the root element, right? Because it was like, this was our root, right? And this was our tree like. So to get till here in Postorder Traversal, I will have to skip all these elements and then I will get to the root of left subtree. So how many elements do I have to skip? All the elements in right subtree and all of the element in the root, that is just like one element, right? So to skip all the elements in right subtree, how will I skip it? So we have this end, right, that is pointing to this. In order traversal, it's pointing at the end, and we have the index of the root value. And I already told you that this, after the index, all the elements represents the, after the index till the end, it represents the right subtree. So can I say that number of elements in right is nothing but end minus index, right? This is the number of elements at right. You can see also, like we have 2 elements in the right subtree and we have end is 5 and index is 3. So 5 minus 3 is 2, right? So we'll get like the number of elements in right. And how many number of elements in root? We just have like 1 element in root. That is like common sense. So we have a total of 3 elements. We'll get it like that. So what I have to do to get to the left root, I will have to skip 3 elements. So what I can write, like root index minus, you can just say end minus index plus 1. These many elements I will have to skip to get to the root index of left subtree, right? This will be the formula that will be used to get to the root index of the left subtree. Then again, what will happen once I have found this, like this is the root index, right? I'll find my element, that this will be the level order, this will be the in order traversal for my left subtree. I'll find my root in here, it will get me here, this will become index, right? And before that, all the left elements will be there, and after that all the right elements will be there, and recursively like the other trees will be formed, right? So the main thing was this only, to get the root index of left and right, and to get the start and end of for both left and right. So for a root, this was nothing but n minus 1, right? The end element. Start was nothing but 0 and end was nothing but n minus 1 for a root element, like the root element of the main tree, right? And the root index was for post order and start and end were for the in order, right? And through start and end and through our root index, what we will get? We'll get some index when we loop. This will also be in order. We'll find that index in order array. Now for root of left, what will be the root index? It will be root index, the index that we found, minus end minus index plus 1. This end and this index will be of this root element, right? What will be the start? It will be the same as the start of the root element. Here I have written 0, but when we do it recursively, the start can also change, right? So I will just write start, and this start represent the start of the root element, and what will be the end? It will be index minus 1. Right, then again we'll get some index in this tree, right? And all similarly for right, I can write, we'll just decrement the root index by minus, right? Just 1, and our start will be index plus 1. This index will be again of root element, and for end it will remain the same, right? So these are the 3 parameters that will change in our function. So what our function will take? Our function will take a root index, it will take start, and it will take end, it will take post order, it will take in order, and it will return a root node, right? It will return a root node. Now because this will be a recursive function, so we will also have some base case, right? Now what will be the base case? There are only 3 parameters that are changing, right? Post order and in order arrays are as it is in every call. These 3 parameters are changing. You can see like in root left and root right, these are changing. So what will be our base case? Because we are decrementing our root index whenever we are changing it, so our base case will be like root index should always be greater than equal to 0, right? If it becomes less than 0, then there is a problem. That means then there is like no node left, so we will return null, right? This should be the first criteria. And second will be, because start and end are changing, so can I say that start should always be less than end, right? Should less than equal to end. This should also be a criteria, because if start becomes greater than end, then we cannot like run a loop, right? How can I find my index if start becomes greater than end? So these will be our base cases, and if any of these criteria is not met, I'll just return null, right? If any of these criteria is not met, right? So there is a lot to like take in this question, but when I write the code, you'll understand all of it better. There are just like two main things that you need to know in this is like this. First observation, that the last element of the post order array will be the root value of root, and these are the main things, like how our root index is changing and how our start and end of the in order is changing, and the base case also. Like base case is also something you need to understand. So once we do the code, you'll understand all of this better. So let's see the code for this question. So in this question, you will be provided with this function build tree, right? Let me just zoom. And in that function, you will have Inorder and Postorder array. So what I have done, I have created one more function called solve to help us solve this question. And in that solve, what I have passed a root index, a start, end, Inorder and Postorder. What I told you in the explanation earlier, right? So for the root, for like the main root, what is our root index? N-1, n being the size is nothing but the like number of nodes, total number of nodes in the tree. So n-1 is the root index, that is the last index in the post order array, that will represent our root value. 0 is the start, like from the start until the end, n-1. So the whole in order array will search initially, and then in order and post order I have passed. So in like this solve in this solve function, you can see I have written this base case. So base case was what? Like root index should be like if it's less than 0, and if start is greater than end, we'll return null, right? So this is what we talked about. We talked about like what should be the criteria, like it should be greater than equal to 0 and start should be less than equal to end. So like this is like basically the opposite of it. If like any of these is happening, then we'll return null, right? Then what I have done is I have created this like root, a new node, and I have passed my value. So what was the value? The last index of the post order that we have passed, n-1, right? Root index. So in the post order, that at the root index, that will be the value of our root. So I've created this new tree node, and then I've created this index variable. And what will be the index variable? It will be nothing but the index of the value of our root in the in order array. So I have traversed from start till the end, right? This is how I will traverse in order. So, and once we find that I, where the value is root of value, I'll make it as I, our index variable will become I, and then I'll break from the loop. So, and then what I've done, I have just written for the left and right subtree the recursive function. So for the left subtree, our root index was this. This is the formula that I wrote: root index minus n minus index plus 1. Right? Through this, we'll get to the root value of the left subtree, and start will be the same, and the end will become index minus 1. Right? And for the right subtree, root index minus 1 will be our root index, just decrementing it, and start will become index plus 1, and end will remain the same for the right subtree, and then finally we will return the root. So I'll just run this code. So as you can see, it's running. I'll submit it also, and it is submitting, right? So yeah, so this was the code. So thank you so much for watching this video. Please do subscribe to Inspire EDUCARE channel for more such content. And yeah, thank you so much.